For question 9C from recitation, we're given that we have this 0.5 molar solution of lactic acid and the Ka of lactic acid, and then we're told that to that solution we add a 0.3 molar solution of sodium lactate. Based on that addition, what is the pH, what is the new pH of this solution? And so this is a common ion effect question because we have this equilibrium, right? I've got lactic acid. Lactic acid is going to react with water to form hydronium and lactate, the conjugate base of lactic acid. I have that at equilibrium, right? That's aqueous, that's aqueous. And then to that equilibrium, I add the strong electrolyte, sodium lactate. So sodium lactate, I put that in solution. Right, that ionizes completely, gives me sodium, which I don't really care about too much. And it gives me lactate, right? This is a common ion effect question because now I've got two sources of lactate in solution, from my equilibrium of lactic acid and from the addition of sodium lactate into solution. Okay, so based on this concentration, the addition of this counter ion, what is the new pH of this solution? Right, so we can set up an ice table if you want, right? And I'll say I've got lactic acid, I'll call this La. I've got hydronium and then lactate, which I'll just call L. So I've got my lactic acid, I've got hydronium, and I have my lactate. I have my initial, my change, and my equilibrium concentration. Initially, I have 0.5 molar lactic acid. I have 0 hydronium initially, and initially I have 0.3 molar lactate. That is from the sodium lactate because the sodium lactate ionizes completely. Okay, I'm going to get a change, right? Some of the lactic acid will go into solution, so that's a negative X. That'll create some hydronium and some more lactate. However, this change, because this is a weak acid, this change in concentration will be small enough that we can ignore X with respect to our initial concentration. We do have to find X here because that's tied to our pH, so we will find X with respect to hydronium, and we can also ignore our X here with respect to the concentration of lactate from sodium lactate. Now we have an equilibrium concentration for all three species in the reaction, or we've defined it as a variable that we can solve for. So I know the Ka for this solution, right? We can write out the expression Ka equals the concentration of lactate, right? The conjugate base times hydronium all over the concentration of lactic acid. I know the Ka is 8.3 e to the negative 4. That equals my concentration of lactate is 0.3. Hydronium is my X all over my concentration of lactic acid, 0.5 molar. Multiply that 0.5 across, and I get 0.3 X equals 4.15 e to the negative 4. Divide both sides by 0.3 to get X, right? And remember, X is my concentration of hydronium. So when I divide that by 0.3, I get a concentration of X. X equals approximately 1.38 e to the negative 3. And that's a concentration in molarity. And that X, remember, X is hydronium. So to find the pH, right, pH equals the negative log of hydronium. I just found the pH, right? I just found the hydronium. So pH equals the negative log of 1.38 e to the negative 3. Negative log of that gives me a pH of approximately 2.86. So again, this is a common ion effect, so we would just set up the equilibrium for lactic acid, and then once we have that set up, we can set up, I add sodium lactate to that. What's my change in concentration? Set up my equilibrium expression knowing that that strong electrolyte will change my concentrations initially, and that will show up my equilibrium expression, and from that we can find what is the concentration of hydronium in the presence of sodium lactate.